Hi, I'm Steve Endo, and I'm a Microsoft MVP, and today I'd like to talk about measuring latency in complex Power Apps, and specifically tracking elapsed time within a Power App. So what do I mean by complex Power App? Well, in this context, I'm talking about a Power App that has several dependencies or has complex operations. And in the example I'll show you, I have a Power App that calls a flow, and that flow calls an Azure function, and that Azure function queries an Azure SQL database. So I want to understand latency and elapsed time in this entire chain of events within my Power App. So when you have a complex application with numerous operations like that, latency will likely be a concern. And so I want to design my application so that I measure and expose elapsed times throughout each element of this solution. So in this screenshot, you see that I'm measuring my Azure function, my flow, and my Power App operation. So let me show you an example of how I've tried to perform these measurements in a sample Power App. This is a sample Power App I've created to generate complex passphrases. And so you see I can choose the number of words, I can choose the maximum length of those words, I can choose whether to include numbers, symbols, spaces, and even misspell the dictionary words. And once I click on Generate, it calls a Microsoft Flow, which calls an Azure function, which queries an Azure SQL database in order to get the word list. And then that Azure function builds my passphrase and returns it to the flow, which returns it back to PowerApps. And you'll see at the bottom here, I've actually exposed how long it takes for the Azure function to do its job, for the flow to do its job, and then finally for PowerApps to perform the entire operation and return the result. So in order to do that, let's start by looking at what I've done in the Power App to measure latency or elapsed time. So when I click on the Generate button here, it has a function to record a start time, perform the call to the flow, tell the flow to run, and then capture an end time. I don't know how precise this is or how accurate it is, but it does seem to work, and the numbers I'm getting back do seem to be recording the overall elapsed time for the Power Apps operation. So I'm basically just storing the current date time using the now function into a start time variable. I'm then recording the same type of now operation into an end time variable. And then what I'm doing is at the very end, I'm performing a calculation of end time minus start time and saving that into a duration variable. So that's how I'm trying to measure the total time it takes between when I click this button and it calls the flow and when the flow returns and it finalizes this button click event. So then we've captured the Power App total elapsed time. How about the flow? So let's go over to the flow here. You'll see in the flow, right when PowerApps calls it, I record the start time. And I do that by initializing a variable called flow start time, and I store the current UTC time. So let me just edit that so we can see that. So I store the UTC now value in flow start time as a string, and then it captures the parameters from PowerApps. It calls my Azure function here via HTTP, and it gets a response. And at the very end, after it gets that response back from the Azure function, it records a flow end time using the same UTC now function. And then lastly, in order to calculate the elapsed time, I have a function to subtract the end time minus the start time and divide by 10,000 in order to convert the ticks to milliseconds. So that's how I'm getting a millisecond result in the flow elapsed time variable. And if we go back to the run history, let's take a look at the last run that succeeded. You'll see the flow start time recorded this time, and then the flow end time recorded that time. And then let's go back to our HTTP call. We see that the Azure function has an elapsed time that it returns along with the passphrase and the length and the version and a message. So that's embedded into the Azure function. So essentially we're capturing the Azure function runtime here, and then we're calculating the flow elapsed time here, and we're returning that into PowerApps. So once we're back in PowerApps, after the flow is run, we were able to display the passphrase that was returned. And if I click on this PowerApps, I basically say, okay, display the PowerApps duration here. So convert that into milliseconds. And the duration is the difference between the start time and end time on the generate button. So with that math, we should get milliseconds. Then if I click on the flow, this is just displaying the response from the flow that I called flow elapsed time, that value in milliseconds. And then similarly, I'm just returning the elapsed time from the Azure function. So that's what .elapsed is. And so by doing that, embedding elapsed time value in my Azure function response, by calculating the elapsed time in my flow and returning that to the PowerApp, and also by calculating an elapsed time in the PowerApps itself, I can see that the Azure function took roughly 300 milliseconds, the flow took a total of 900 milliseconds, so roughly 600 milliseconds net for the flow to function, and then we went from 922 to 1858 for the PowerApp, so roughly another 900 milliseconds for the PowerApp to run. Now, that may not sound like a lot, and 322 milliseconds is fairly fast. User probably wouldn't complain about that. But when we're looking at a total response time for the user of 1.8 seconds, let's round that up to 2 seconds, there is a noticeable amount of latency there. So let's hit play, and let's see what type of numbers we get. And I probably haven't run this for several minutes, so the flow may need to spool up and the Azure function may need to spool up. So there we go. So Azure function this time took a second, flow took 6 seconds, PowerApps 9 seconds. So pretty significant, but that should reduce if we run it again, hopefully. There we go, much better numbers. So 700 milliseconds on Azure function, 1.4 seconds on flow, 1.8 overall for PowerApps. And one thing I've noticed is in this chain of resources, PowerApps, flow, Azure functions, Azure SQL, there is quite a bit of variance in the latency and elapsed times that you'll get. So here, previously we saw 300 some milliseconds, now we see 700, now down to 400, so 4811. And now, wow, 37 milliseconds to 600 to 1200. So you'll see quite a bit of variance. And normally on an on-prem solution on a dedicated host, you'd see much lower numbers and much more consistent numbers. But since we're dealing with SaaS services like this, you are going to have higher latency and significantly higher variability. But overall, it's an acceptable number. So 1.2 seconds for this particular application, given what it's doing, that's not too bad. So we're up to 1.5. So I thought that was useful for me and thought I'd share that because I was concerned with this solution having a PowerApp call a flow, which calls an Azure function, which relies on Azure SQL database, that I might run into latency problems. But overall, it looks like it's acceptable for this particular use, and I'm actually pretty happy with the results at under 2 seconds overall for the PowerApp response time. Well, I hope you found that useful. If you have any feedback about how I could improve the latency measurement and start an end time calculation, please let me know. You can find me on Twitter at SteveEndo and check out my blog at blog.steveendo.com. Thanks for watching.